Hey, what's up? Welcome. Let's get comfortable. All right. So I got lots of goodies today. Wow, look at that responsiveness. Holy smoke. All right, so since you're here, let's check this out. I'm gonna turn this on. Check my transistors. This is a regular three-phase setup. Apologize if you can't hear me very well. My cameraman hurt himself and he's taking it easy. All right, so this is of course with 25 and an amp in. It's interesting. This whole setup is like, it's cool, but it's there. I turn the light on. You could kind of hear the motor like hiss up, like it got frequency got tighter, and the amps went up by 0.2. But we got this on. So that's the first thing we got going on. And what that is 32 gauge strands, or 30 gauge, one of the two. I think it's 30 gauge strands. And this one, this coil, and this coil. And then these three coils have the same. I linked them all together in a series circuit, and that's what I get out of it. So all those are linked up. Just the bifilar, the parallel, I'm going to call it a parallel wrap, because bifilar, obviously you got to twist it or something like that. These are not twisted, they're just parallel wrap. And so the 30 gauge strand and the bifilar, they're all linked together to do that, but they're all wrapped together with the drive circuit. So they all have drive going through them, because it's like one phase, two phase, three phase, and they all are 120-degree circuits. I love talking about this stuff, man. I could talk about it forever. But what I was going to do is I was going to use these three transistors here, and I was going to hook SG up to all three of them. Okay? And then I'm going to run this motor, and there's a motor over here. And then I was going to do this ball here with this coil that I made. I made my own Vitz wire. This is 16 feet of 24 strands of 26 gauge. Okay. And then I linked them all together. This is in one series circuit. I don't know how well that's going to work, considering there's so many ends. But I got a beat reading and an ohm reading from that, and then that's good to go. So we're going to try and move this ball, spin it with that little coil right there. We're going to see how much power the one series can do, especially multifilar like it is. It's going to be awesome. All right, let me look behind me. Hey, what's up, Mike? All right, man. Good to see you. Yeah. Totally not safe, but awesome nonetheless. All right. Bam. I love having this switch in my hand. Man. Wow. All right. That's enough. And now it does put a load, having all 6 of those strands in series on the rotor. It is a very small load, considering how bright that light is. I mean, it's not as bright as it can be by any means, but it's brighter than you know. It's not its dimmest, that's for sure. So I'm gonna hook up an SG for each one of these transistors, and then we're gonna power the ball. I don't know if I'm gonna hook this coil up, man. This coil looks freaking dangerous. It's not all it's cracked up to be sometimes. Jovis, but good for you. That's awesome. All right. You're very welcome. All right. All right. Let's see here. Well, what I'm trying to do with what I'm gonna do is have the one power input, which for this motor is actually 3, and have it power that 3 power input power this motor, that motor, and the ball experiment at the same time. Hey Noah, what's up, my man? Sorry I haven't turned, cameraman's out sick, so I'm doing the best I can with messages and stuff. I'll try to remember to turn around ever so often, but it's gonna get hairy here in just a second. I was running parallel transistor SGs last night. That was pretty sweet. I actually used a breadboard for the first time with the big transistors. I got them in the holes and everything was good. Whew. I'm going to be using these resistors. Don't think I need all that, but we have another power supply just in case. I always wanted to see if this little, I mean, I don't know if it's a good idea, quote unquote, but I'm gonna hook this up to this collect. I'm gonna stop this first, because there's a whatever a rebound of like 0.5 volts. All right, so I had to move one clip down. Freaking see, I can't see, man. This is terrible. My perception is skewed forever. I don't know why. No, I'm just kidding. Alright, so I don't know, do I want to do it on that one? Or do I want to hook up this one? And we're going to do that one. I don't know if it's going to work though. See, when you can turn it all the way up and your rotor stays still, you've got good transistors. Now this is part, or the end of the SG that I just hooked up for this one right here, without all of the extra components. So really what it is just a continuation, I guess, of the power from the power supply through this system out to the collector, and then it goes both ways. It goes to the transistor and then it goes to the other motor. And it doesn't come back because you have a diode there. Is it working? I don't know. Probably not. Maybe. And it isn't lined up directly. I should probably line it up. Since it's resting on a flange anyway, I should probably line that up. And then we'll get some so we're going to unscrew the nut here, X nut. Move it up about a half an inch. That's lined up pretty good now. This maglev is amazing. Once I got it together the right way, it's absolutely amazing, man. This thing is sturdy. I bet it could go up to like 2,000 RPMs. I mean, the bearings are gonna fly out of there before it like moves around too much. I used to have a huge problem with the shaft shaking, and now that has disappeared. Alright, we're good with that one. I'll hook this other one up. Anybody want to take a wager on whether or not that's moving? This one over here, is it working or is it not working? Is that just my finger power over there or is it working? I don't know. I can't tell. I think it's working. Let's take a look at, this is the part that's hooked up to the light right here. Let me see if you can see that. Yeah, kinda. I'm gonna switch it to the sine wave, or the oscilloscope. Look at that reading. Oh, it's screeching. Woo! Wow, that's so neat. Just messing with the oscilloscope here. We're getting about 500 to 600 volt spikes. I had way bigger spikes before. I had a positive and negative wave. This was basically a positive wave, in my opinion. The spikes are way higher on the top than they are on the bottom. They were equal, and I was pulling about 1,000 volts, like per cycle, per reading. 1,000 was the lowest. And then all of a sudden I heard the frequency change. I heard the sound change from the motor, and it's like the bottom part disappeared. Alright, so that was my finger power. And I'm just checking to see if this is set up correctly. And it is not. We are missing something. So I'm going to hook up this one over here. And then I'm going to get a transistor for that one over there. You kind of want to have it all stopped because they will trigger each other like no tomorrow. We are going to bust out a breadboard for the final build. That'll be later though. We're gonna have some fun right now. That's work. For me, a breadboard is work. It's look at these fingers, man. They are not made to be messing with a breadboard. My handwriting is absolutely terrible. That's why I don't write anything down. I just don't bother because one, I'm probably not going to be able to read it when it comes time, and two, neither will anybody else. Let me see, can you see that? It's in the corner of the... Yeah, let me check that out real quick. Yeah, the microphone. All right, that one is definitely functioning. It's not gyroing. I don't know why it's not gyroing. It's probably because of the type of energy that's coming out of there. But it should that's awesome. I think it's great. And it does move twice as fast when it is gyroing. I'm going to see about that mic real quick. Now, I don't know about how well these are charged up, but I'm going to hook it up real quick. Hello, mic check. Is that really loud? Oh, I hope it goes through since it already started. All right, I'm just going to hold it for now or put it somewhere close because I don't want it brushing up against my clothing. All right. So this is Brian's motor right here. This is his idea that he suggested to me. And it's 3 120-degree circuits with a 22 gauge drive circuit, which is these three. And then there are 2 pickup coils and 120-degree circuits with each drive coil hooked in series to each drive. So it hits in phase. Now I was talking about that. I was thinking about how we could do a north-south arrangement in the rotor. Different types of north-south arrangements in the rotor. Like even having 3 of them north and then 3 of them south, and having a DC motor underneath to spin it. Use it just solely as a generator. So not run it on a pulse motor, but run it on a DC motor like this one is. I mean, you put 5 volts in, you're already up to 1500 RPMs. Like, I don't know. In my experience, they don't compare. I mean, I have a lot more fun with pulse motors and stuff, but like in building stuff like this, and like my experience, stuff like that is what you need to make stuff like this like better when you combine the two. But there's I don't even know if that's right. It's just a thought, you know, that in order to make that work, you would have to have a DC motor. Maybe. I don't even know. I haven't tried it yet. So, oh yeah, that's right. Duh. Cowabunga, man. All right, so this one is all good. This one's functioning. It's running on a reed switch. This one, I need a transistor for. I have these, but I don't think working at 100% efficiency. All right, so what do I do? Do I get a fresh one? I have a fresh one right here. Or do I hook up a reed switch and we do it that way? Yeah, but this the connectors on that Litz coil that I made was a nightmare to get together. But once I did, and I heard the beep on the last strand, I was like, yay! Because it's 24 strands in series. and it's multi-filer. It's twisted. It's done exactly the way the benefactor suggested it be done. And I think it turned out really well. It's just a mess because some of the ends are, the enamel's longer. The end is longer, so there's a possibility that it could short out really easily. All right. Okay. Um, Black one. All right. Let's do this. Stop that. Whoa. All right. It sounds like something's making contact with something. Maybe not. There we go. That's good. No hissing. I think we're good. And we got 2 down. We're going to turn the light on now. Now, it was suggested to me that that each one would bolster the other. Yeah, I don't know about this one over here. I've even got its own uh, timer, its own trigger strand hooked up so that it won't be dependent on this one's frequency. Now I could unhook that, but I don't know if it's going to work really well. Let's see. All right, the base is unhooked. And then we're going to hook up the signal generator for the ball. I don't know why it's not gyroing. I think it's just because the copper is a little sticky. Alright, so let's turn this back on. Yeah, that's better. Alright, let's turn that back on. Alright. Now, when I was making these 6 coils, I had the option of making them single strand or making them bifilar, and I made them all parallel wound. I'm gonna say bifilar because that's, I've been doing it for years. Even though I've now figured out that the bifilar coils are twisted, I guess. No twisting going on here. The only twisting I did so far, pretty much, is this. Like I said, that's 16 feet, 24 strands, all in series of 26 gauge. Now, is it the biggest or the best way to have done it? I don't think so. But I had to work with what I have. That's where I'm at. So, and then when I turn the light on, the power supply distributes 200 more milliamps. Something's not right. And this is a brand new transistor. So I know it's not that. All right. So just for fun, we've got one of these. Now, normally I put power in first, but I don't think I'm going to do that. This. Now you can kind of see when I do this how a transistor works. I just move the collector to one side, the emitter to the other, and there you go. There's your transistor. So the transistor can do it a lot faster. Hello, ladies and gentlemen. This is Papa Bale. Welcome to the channel. And what we're looking at here is we're looking at a pulse motor and a pulse motor and another pulse motor, and then we're gonna try and spin a spherical magnet using well, I'm gonna set them up completely. The SG circuits on these drive coils. All right. Voila, that's working now. This one's working less though. Now there's 2 reed switches on the circuit. It's all one circuit really. Huh. And the funny thing is that motor, the one with the gold ring, and this motor, the one with the blue hat, will continue to run even if this one stops completely. So I think it's going to stop. I don't know what happened. But I like how fast that other one's going. I like how this one's moving still. I don't know what to make of this reading though. Yeah, I'm not sure. I like this though. So even though it's running on a reed switch, it is running off of energy coming off of these coils. We're gonna stop this, start it up again. I like that click. This click over here, it's nice and it's pretty cool. All right. So before thing gets too lost. Thought those would be a little bit easier to find. Huh. My mistake. I love the tools you got to work with sometimes. The Allen wrench, literally the size of my fingernail. Awesome. Oh, I know it sounds that way. I'm really having a good time. All right. So if we're not going to use, should I try this coil? Should I try to put fire through this coil? I don't know, man. I don't know. I'm gonna go get my other multimeter. Make sure, because there's, of course, there's one. There's one loose strand. I think I know what it's from too. From when I wrapped it around the hook there. All right, so I got my pen, got my multimeter, and got my coil. I'm gonna do it on the other side of the table. That makes a lot of sense. I'm gonna have to hook the signal generator up over there. See? That's awesome. But it says it has like 24 ohms. I know that's not, yeah, it could be right. Actually, 24.6. Close. It's really close. Now, if I hooked up three 16 gauge coils with this coil, that thing would be freaking flying, tearing itself apart. All right. Pen, notebook, transistor. Oh man. Leads. I'll have to rearrange that again. All right. Do we have what it takes? Do we need an extension cord? Alright. Transistor. Now there's a 50-50 chance that this thing is going to catch fire. So I'm going to have a glass of water. Huh. Yeah, right. Electrical fire is water. That's funny. No, I'm just joking. Oh man. Damn, I really don't want to do it over there. So I don't want to do it on the ground either. Oh, that's so rough. We're gonna have to do it over here. I'm gonna have to clean off something real quick. Got my heat sinks. A bunch of transistors, resistors. This. Plug this in. That's so much. I want to at least get the plastics off of here. All right, now active coil. Take the coil, bring it back over here. Transistor. Man, it's amazing how quickly stuff gets wrapped up. Okay, we're going to take coil. It's not the right one. Take the transistor. I'm trying to make a spot for this. There we go.
Now, power. Now I gotta do. Where I put that good spot. Anybody can scope out my other multimeter? There it is. Got it. Gotta make sure that I am, because there's an extra lead there in it for where I tied it off. Make sure I don't hook up the wrong one. That was a pretty solid beep, so I'm thinking it's good. Thinking it'll work. I don't know if it'll be as strong as the 20 gauge with a different style wrap. But we will find out. Alright, now we gotta hook up the transistor. Here is another light. So gradually we will find all the components. 2 neon lights. Go. 3 neon lights. So we're good for that. It's been a while since I did this, so I don't know exactly how everything's going to react. Oh, I want a big one. Maybe like that. Not this little white one, but wow, that was pretty impressive. All right. Hook that up here. Oh man, we are out of slots. So I have to hook up. Hook up ground here to the emitter because no more spots. Well, I could do one thing, but I don't think one enough. So usually I hook it to the ground. All right, so we are going to go frequency. We're going to go. started 7. Lucky number. Here we got 5% voltage amplification, 0 offset voltage, and 50% duty cycle. And try 20 volts. And change the duty cycle to 24.6. Wow. And this is all off the extension from the transistors. So I don't know what this is going to work like that. I have another bowl that I want to use. Wow. That's pretty careless. All right. So I want to find maybe I should clean it off. I don't know. There's some old ferrule fluid on it. I think it might be acting kind of like rubber at the moment. Wow, the pulse going through this thing is amazing. I don't think it's a very strong magnetic field though. I'm gonna try it. Just try wiping it off. Now, man. Nice and shiny. All right. I do not see another bowl type thing. I don't know if this coil is going to work. I think it feels kind of weak at full power on this motor. So I might have to switch it to the other power supply. Well, when I hold it up, it spins for a lot longer. That's pretty interesting. I guess it's not spinning, it's just kind of rocking back and forth. I know what does work though. That 20 gauge coil right there. Wow, I can feel it though. It's really pulsing. There we go. Not in the middle, but it was spinning. So like I think 26 gauge is a little weak on the magnetic field. It is 384 feet though of 26 gauge. It's kind of cool, I think. Don't think it's going to work though, not with that coil. Yeah, this isn't good for reed switch. This whole setup is just not good, especially doing it on the fly. But there we go. Not good. That's better. There we go. So the only we probably use a different coil and it'll work better. All right, so I'm gonna turn this off. Turn that off too. I really want to set up my 90-degree times 2 coil connection though. See how well it works with 2 working transistors. That's how I want to see it. I want to see it work like it's supposed to. But that's the next thing I'm going to do. I want it for the center, like right here. And I'm going to use thick wire. I'm going to use big coils. Well, this size coil. I want the magnets to interact with the entire coil, or at least most of it. It doesn't have to be all of it. It just has to get, you know, the imprint has got to reach farther than the magnets. There's got to be, it's in my head. That's all I got to say. All right. So this will go here. And this will go here. Bang. Okay. right along. Gonna need to get a drink soon. All right, let's put the ball back on there. Now the ball is reacting to the two motors. That gives me an idea, actually. I put it right here, and then I spin this one and spin this one. We'll be able to spin the ball in the middle. Maybe we can check it out. Of course, it would have its coil underneath it to I think that happens because the thing was on. Bang! And it worked through all the way through like two transistors. Awesome. Without even it being on, really. All right, here we go. All right, we're gonna turn this on. That's frustrating me a little bit because as soon as I yank on that, everything's gonna go flying. Just know it. Oh yeah, that's pretty strong too. Now we're at 815. All right, I'm gonna have a little fun. 2,000, 2 kilohertz. All right, nothing. Mm. Yeah, no. See, it's interesting because these two motors are making this ball move. So I don't know. Having two reed switches on this motor though is kind of bogging it down, I can tell. Because they're not in sync and this one isn't sped up yet. But it's active now. You can hear it. Slow down as soon as you could. Oh yeah, let's make it slow down even more. Got a light there, but you can hear it like squeak up. Now I got that ferro fluid. Should I put a little dab in there? Get it lubed up? Should I put some graphite powder in there? Let's see if my graphite powder isn't like right here in the open. I did not see it. There it is. Ah, I knew I had it. Yeah, we're gonna lube this thing up. See if that will help. All right, it's gonna get messy now. Nothing I can do about it. I wish I had gloves that fit, or gloves at all, but I don't. So here we go. Yeah, that's a much smoother spin. Okay, let's go. I wonder what's going on with that. Oh, it's happening. No. Do I need to put more power in, or do I just need to jump start it? What do I need to do? With that being said, I'm going to switch power supplies. What we lose is our ability to read amps. I don't have an amp reader. It's hooked into my 24-volt power supply. All right, so here we go. Oops, wrong one. Go up to 28. Oh, what's going on there? Oh, that's not good. One of them's blown out, or it's touching somewhere. Yep, that's not good. I don't have any idea which one it is. But you can tell, this is how you tell when one's blown out. You stop it, you put any kind of voltage through it, and it'll kick like that. That's no good. Well, it's fun. Huh. See here. We're going to start running one at a time. I'm going to turn the fan on because I'm getting, this one's hot. This one's hot. I'm going to put that one to the side. All right, here, down to 1. Let's see what we can do. Unplug this. Here. That one's gone too. Oh, this one is definitely gone. All right, and that is just one series circuit for the light. Only 2 coils. we're not doing it right now. We're just recuperating from me being a dumbass. All right. So, wow, that feels good. Woo, woo, woo. All right. See all these glasses? They used to have liquid in them. I'm like, I feel like I'm in a desert. All right. I have to take a break in a few moments. Get a glass of water. Yeah, yeah, I just don't want to get out the breadboard right now because so all I really want to do is hook up this light. All right. Emitter. Yeah, I had it all on a breadboard last night and it did not function. Like the connections weren't good. And I did it like 3 times. And I'm just not satisfied. It's right here actually. I think what my problem was in the end was that I had all my emitters hooked up on the one negative line, and it works better when they're connected separately for some reason. All right, that. Now, what we want to do, if this one is any good, or here. Hello, everybody. Thank you for dropping in. Just putting some stuff together. Haven't gotten the ball to spin for very long today. I think it's because it's been marinating in ferrule fluid for a good month now. I wiped it all off. Still haven't gotten it to spin, but it feels. I got some graphite powder in there now. It's starting to feel a little loose. Yeah, I don't have the right type of bowl or holder to allow for that to spin for a long duration of time. I'm gonna put a little bit of the graphite powder in here. A little bit of graphite powder, and oh yeah, that's gonna be fun. All right. All right, we'll use this one, and we'll get our light on here too. I don't know if they're gonna work. Half the time my lights don't even turn on. I mean, and I'm getting a feeling like maybe it's supposed to be that way, but I don't know. Maybe it's only supposed to happen when there's a certain amount of resistance needed. I don't exactly, understand why everything works the way it does. And then this hooking the ground to the emitter, I never do that. I always use a separate ground connection, but I have to do it now. I mean, I don't like it really. It doesn't work as well. Something about it, like slows it down. Oh, yeah, we got one more to go here. I don't know if these are working. Let's turn this on, make sure it's working. Nope. How did I miss that? Or maybe I just, it's this damn. See, if it was in a breadboard, all I'd have to do is switch out the transistor and everything else would be good. But I'm not going to frick around with something that isn't going to work on like the 5th try. I'm just not going to do it. Everything breaks. I don't know, man. It's really kind of discouraging, the whole situation. But you know what? When it's working, when it's on, it's gold, dude. And it was working for half the stream. So I mean, I'm kind of working. All right. Oh. You know, I'm not even going to save these. I'm not even going to bother. I already have 2 bags full of them. I'm not even going to bother. Because they're not going to work ever again. So, bada boom. In the trash can. And they're probably not supposed to go in there, but I don't want to look at them anymore. So, those ones went in the trash can. There's tons of them here. I mean, okay. Those are kind of like my best transistors too. We got this one that's working. I'll take the load off of it. I know I'm going to leave it the way it is. Yeah, see this light? It's not lighting up. Probably burnt out. Like all the stuff is burnt out because it's. I use way more voltage than this stuff requires every day. Every day. But that's good. That's working. It's falling from one to the other. That's okay. Yeah, today's been a really odd day for this motor. I mean, when I started off this morning, I was generating spikes of up to 1200 volts on the regular. And then I heard like it just thing, like it broke. The frequency just totally changed, and half of the energy just disappeared. No, the sound of the motor changed. Therefore, it was really doing that, and then it changed to doing something else. I was like, "Dang, how did that happen? What happened?" And I'm figuring that there was like a crossed wire somewhere that amplified the amount of voltage going through the circuit, something like that. And I really don't like how slow this thing is going. It's all right though. Really nothing more I can do because like all my transistors, I got 2 more to look at. And then I got one more. I got a few more different types, but I'm not going to hook them up to this thing. I want to use them on my 4x2, my 90-degree times 2. Wow. All right, so it looks like it's moving a little bit. two. One of them is only working halfway though. Kind of hear it squirting. There it goes. Wow. All right. Kind of. There's a better way to put that out. That's only two. Uh, uh, two of the six, four of the six. So two of the six, two of the three, four of the six. God, it's so confusing sometimes. Only two of the 120s are hooked up right now, so that's what's showing on here. So got one more of these to look at. Let's hope this baby works. It's all right. It really is. As long as you don't maintain being in a discouraged mood. It's okay to get discouraged. It really is. I don't know what this movement is against negativity 100%. I mean, negativity is a part of life. So is positivity. But if you have too much of one or the other, your life is out of balance. And that's just a fact. Because you learn. You learn from both positive and negative experiences in your life. I think we're good. I think we're good. Yeah, we're good. They're not. They're not 100% by any means. Good to go. That way is a lot different. Third coil hooked up. I wanted to put toggle switches on each of the circuits. So you can go like 1, 2, 3 and actually see the difference. Like that. It'd be sweet. I have them. All right. Hey, what's up, everybody? Thanks for coming by. This is awesome. I'm really enjoying myself here. Let me think. What do I want to do? I want to hook up. Wow, man! When I was feeling the pulses going through this coil, I was happy. It was like it was awesome. It felt so like smooth compared to this one, which is a little rigid. Huh. This coil is a 20 gauge coil, 666 turns. See, even though it's moving, it's clipping along, two of these transistors are working at half strength. But I don't like have any to replace them with. So yeah, 500 RPM is what we get. We don't need RPMs to make this work. We don't need this to go fast at all. We don't really need to be moving at all. Make all this other stuff run off of its power connection, which is this 1, 2, 3. Plugged right into the power supply. There's no hook. There's no clip. It's just tied, screwed right into it. I want to run this 4-banger over here, but I want to put 3 more coils up. Hello, ladies and gentlemen. Welcome to the channel. Really appreciate you guys stopping by. I'm going to take a break here in a second and grab a glass of water. Said that 30 minutes ago and I never went to do it. But I'm going to go do it now because I'm really hurting. Bam. That's going to be awesome. All right, I'll be right back. Hey, I need some water. What are you doing? All right. Hold on. Wait. There's a time I want you to spin that, okay? After I start this one. All right. All right, go ahead and spin it. I think it goes the other way. The other way. That's good. No. Nope, that's good. It's not going to work right now. I don't know what's going on with it. It might be the fact that I'm using the energy off the collector that it won't gyro.
Did you make this?
Yeah.
You made it this way?
I cut it into that shape, yeah. Careful with that. It's sharp. All right. You're going to play Gorilla Tag? Sweet. Mm-hmm. 6. All right, so yeah.
Finance, experimentation, slide on them, and some sort of
That's cool.
love that.
Yeah.
Sometimes I go to the cosmetic store.
Bye. All right, we gotta cut the power. And then sometimes you gotta get a little aggressive with your pulse motor, especially with 16 plus gauge. When you don't feel like being gentle, you gotta go with the thicker wire. Mm. Awesome. Awesome. Thank you. Thank you so much, ladies and gentlemen. Really appreciate that. There's like this freak of nature stuff that happens out there. It's like 1 in a million that it'll happen because it's mathematically a certainty that it'll happen, but it never happens, kind of thing. Like getting struck in by lightning while you're inside a car. That can happen, but it never does. But people like when it's raining. That's a bad example because we don't want the inside of the car to get wet. They roll the window up. They don't want to get struck by lightning, so they roll the window up. Is that going to help? But the rubber, the car is grounded, so the lightning is going to strike the car, and it's going to ground like instantaneously. So you really don't have to worry about it unless it strikes you. If it strikes your car, you're fine. Oh, come on. let go. Ridiculous how much you want to hold on. Maybe doing the sphere tonight is a little bit too much. We'll see though. It's kind of getting in the way. And I don't really want these two things to be as one. So come on, man. Frick. All right, I think we're good with that. But hold on. Geez, please. All right, so this one. Okay, so that's hooked up already. What am I missing? I think it's this. No. I think here, last, this one. Now we just need to find. Now we just need to find this one. Ah, got it. That's probably what the problem was all along. All right. Might have to glue these down. That's not cool. Well, maybe I'll be all right. All right. That's good. We're going to take the meal ball and then we're going to put it off to the side for now. Ah. All right. So I don't understand why the main rotor doesn't have to spin in order for the other stuff to work. That kind of just means it's an extension cord, honestly. Spun it the other way, I don't think it's going to do anything different. I tried to keep it clean, but I got like every. This is, uh, all right. Since this isn't really working, I'm gonna turn it up. We're gonna see if we can't get the other two to spin faster. Oh yeah.